In this video, we will walk through making all of the instrument and trunk line connections of an MIHPT system. We will turn the instruments around and begin by adding power cables to the HPT controller, field instrument, MIP controller, and the XSD controller. The gas chromatograph already has a power cable molded into it. Next, we will connect the serial communication cables. We'll connect first the HPT controller to the MIP controller, and then the HPT controller to the field instrument. Which instrument, the FI or MIP controller, is connected to the top or bottom port on the HPT does not matter so long as they're both there. Now I'm going to connect the gas line fittings to the MIP controller. The first connection I'm going to make is an 1/8 inch to 1/16 inch reducer fitting on the outermost bulkhead labeled regulated output. We will later connect the trunk line supply line there. On the carrier gas input connection, I have a larger T fitting that will bring clean nitrogen from a high pressure tank to the MIP controller as well as to the gas chromatograph carrier gas connection, which I'm going to connect next. The T splitter can be positioned either at the MIP controller, gas chromatograph, or the nitrogen tank regulator. Next, I'm going to bring a piece of 1/8 inch peak tubing, primarily to show the difference in gases, to the hydrogen bulkhead of the gas chromatograph. The other end will connect to the hydrogen tank regulator. The next connections we will make are the detector signal output wires from the gas chromatograph and the XSD controller to the MIP controller detector inputs. Geoprobe typically configures the green terminal connections to have the PID and FID in detector position 1 and 2, and the XSD in position 3. Detector position 4 will typically have a loop of wire which is able to keep detector channel 4 baseline near 0. I'm taking the opposite end of the XSD signal cable and connecting it to the signal output port on the XSD controller. Now I'm going to bring over 2 more cables for the XSD and connect those into their inputs. First is the detector signal in from the detector cell, and then the reactor power cable. And you'll see where those connect into the controller, reactor power, and signal in. The opposite ends I'm going to feed through one of the 2 openings in the rear of the instrument lid. The next step will be to raise the red lid of the gas chromatograph and insert the XSD cell into the base as I'm doing here. Place the signal out cable into the fitting on the end of the detector cell, and then take the red reactor power cable and insert it into the fitting that's facing on the upside of the detector, as you can see here. Next, we will connect the water supply intake and bypass lines. The supply intake line is the larger of the 2 polyurethane tubes. Both get connected into the lower left corner of the rear of the HPT controller. We will need to tighten both of these fittings and then place both of the lines into the water supply tank. Now it is time to connect the trunk line to the instruments. I am using connections from a breakout panel, however these can be made directly from a trunk line. First, I will complete the HPT connections by inserting the nylon HPT injection line into the press fit connection. Next, I will insert the HPT sensor wire terminal connection into the receptacle. Notice the top-down order of the wires are brown, orange, and red. Electrical connectivity wires are placed in the top 2 spots of a green terminal connector and should match the top dipole or TD display on the instrument when connected. The yellow heater wires are next. They get mounted into a 4-piece connector, which I show here. Make sure you have disassembled and reassembled as displayed. Next, line up the slot on the receptacle and insert and turn to the right to engage. The thermocouple wires are placed in their connector, yellow positive and red negative for proper temperature display, and they cannot touch each other. These wires are under and outer jacketing material. Finally, we have the MIP carrier gas lines. I will first connect the clear Teflon gas line to the regulated output port on the MIP controller, which will supply nitrogen down to the probe. The return gas line is tan-colored, a plastic polymer called peak tubing. We will feed it through one of the openings in the rear of the GC and connect it to a 1/16 inch bulkhead which is located behind the PID bulb. Ensure that all connections have been tightened. To record sensor response versus depth, you will need to connect a string potentiometer. The plastic side of the orange cable connects to the field instrument connection labeled string pot. On the string pot side, we will connect the metal end of the cable to the string pot. Just press in and twist. When the machine is set up on a logging location, you will connect the string pot cable to a location on the machine and set the string pot on the ground next to the machine directly below the connection point. Lastly, we will place a field laptop with the instruments and connect a USB cord from the field instrument USB connector to the laptop. This connection will allow us to operate the DI acquisition software. Next, we will quickly review the connections at each instrument.